Thank you, Chip. Hello, everybody. In case you didn't know, we are here discussing the dealing with data, breaking down the process from collection to actual actionable insights. The target audience, basically, and the real meat and potatoes of the discussion is really geared toward people who are product managers and aspiring product managers that deal with a lot of or a large volume of data and is interested in knowing more about sound collection and reporting. But allow me to introduce the individuals that you're here to see. First, I have Mr. Mark Light, the VP of Data Science at Census.io, a cybersecurity startup where he supports a research team and works to enable impactful data science and machine learning driven features in Census products. He's successfully practiced impactful data science at 10 organizations over the years and in a number of different industries. Next, I have Miss Lucinda Lindy, a business focused data scientist at Ironside, where she delivers business value by applying machine learning to business problems. Some of her work involves building machine learning models to support a variety of use cases, such as predicting wait times in retail, best products to sell, and fraud detection, just to name a few. And last but not least, we have Mr. Razi Razudin, who's the CEO and co-founder of FeatureByte, an AI-ready data management company based in Boston, where he spent the last 20 years in data and AR startups, including two unicorn companies, Netiza and Data Robot. And me, I'm Ralph Majet, data engineer that basically specializes in turning complex business problems and ideas into fully functional and scalable data products by adding value by wrangling, transforming, and streaming the data to output clean and comprehensible data to my end users. So let's start right off, right? Data is very important, and it's the foundation and basis for all types of reporting and analytics. And it's always good to have a good foundational strategy when you come towards that. So, as we get into our first topic, how to lay down the foundation for a long term data strategy, we ask ourselves, where's a good place to start? Data maturity level is actually a good place to start. And that'll lead us into our first question. How do you gauge your current data maturity level? And I'll open it up to the panel.
Hi, I'm just going to share a slide, an example of looking at data, data maturity. So a lot of times I want to just understand something, looking at an example. So one way of looking at data viability and maturity is, well, the question is with regards to what, right? And I think it's one way of framing how data can be valuable is can it be fed into a business use case? And can you guys see this slide here? Okay. So one way to look at that is to look at the demand forecast. So look at different use cases and then say, well, for a demand use case such as a demand forecast, how does that access things? How does the data flow into that? So some aspects of data maturity are that access to the data quantity, data quality, data variety, and implementation. And I'll just take like a sentence for each one of these. Data access. If you can get data on a regular basis, get it easily, it's not siloed, it's not locked up in spreadsheets, then that is a good data access. If any of those other conditions exist, then that really will limit how frequently and how scalably you can access data for your application. Quantity is important, especially with machine learning, or even for any sort of analytics or dashboard where you want to have confidence intervals, 95, 90%, then you need to have a good quantity of data for the things that you're trying to predict or analyze. Data quality, obviously very important. If you have a lot of outliers, duplicates to confound what exactly you're looking at, missing values, etc., that can really impair the quality and therefore the usefulness of that data. Data variety is actually important. Just recently, we were building a machine learning model. We found that if we just added one piece of data from a real-time portion of the data, it greatly improved the what was going on. You can also add data variety by putting in, by getting outside data sources. For example, if you're selling hospitals, there are some wonderful data, third-party data sources. If you're a bank, looking at demographics and census data, income, number of businesses, et cetera, that might be very helpful there as well. And then the implementation, how reliable, how robust is the implementation? Is it going to be able to scale really well? And after that, you can really say, okay, in terms of our data, this is how it is. This is one way of looking at data viability and maturity for the business use cases that can help drive the value to your company. And I'll leave it at that.
So much, Lucinda. Does anyone else in the panel have anything to add to that?
I guess you could add just what kind of controls do you have? So if you have any kind of privacy, any data that covered it in some kind of contractual thing or regulation, GDPR, do you have those in place?
Also valid, good point. Also, it's also very important to take into consideration your organization's maturity to understand the literacy and manage the data into account. So basically, it's always important to proactively invest in developing the data skills of your own staff from top all the way down. Transitioning on to our next question, does your company size and industry play a factor in determining between centralized versus distributed approach to your data strategy? I'll leave it open to the panel.
Yeah, I can jump in, Ralph. Yeah, indeed, and the size as well as the industry plays a pretty significant role. I think when obviously we're in startup Boston, so most of the folks I'm assuming are from startups and small companies. With small companies, I think it's critical to centralize the data strategy and build a really strong foundation. That's pretty much the best way to go, especially when you're collecting and processing data and processing information. Especially for startups that are focused on sort of building products and services that are focused on analytics or AI. I think it's pretty critical to have a centralized way of collecting and managing some of the data. And then as organizations grow, I think the needs of the different departments and different groups start to vary quite a bit. As an example, I'm working with a fintech company that's that started in Latin America, and so initially a lot of the markets and countries that they were focused on were quite similar, and so they started with a very centralized way of starting the data collection and data processing, and then now they're branching out and going to Asia and going to the US, to North America. Obviously, the entire market is very different. The needs of the clients, the needs of the market are significantly different. And that's where a decentralized, much more of a distributed way of kind of approaching the data strategy makes a lot more sense. And I think, obviously geography and industry play a significant role as well. I think, Mark was mentioning about the ability to, thoughts on regulations as well as data privacy, et cetera. When it comes to regulations, especially if you're in a regulated industry, it's better to have, centralized control over not just the production of data, but also many times consumption of data. And I'm sure, Lucinda, you've, as a data scientist, you've experienced this quite a bit, where there are certain regulations where you even need to be cognizant about what data is being used for analytics and for modeling, right? Especially around credit risk and any sensitive type of models that get built. And there, having at least a centralized control, if not a completely centralized strategy, I think makes a significant difference. I don't know, thoughts, welcome thoughts from you guys as well.
Lucinda, do you have anything to add before we moved on?
Yeah, I mean, I just want that actually, Razi figured out or mentioned a really very important application. One is in banking. and looking at, there's certain demographics you're not even allowed to look at when building a model. Another one, of course, is patient privacy and anything to do with healthcare. So even if you're not putting their name and everything there, but if there are other data that kind of indirectly can lead you to that, to the individual person, then you need to be very, very careful about that. So yes, compliance, financial compliance, regulatory compliance, all that needs to be built in. And yeah, it really makes sense to have a central control or access when thinking about your data in those situations.
Great point. Great point. Moving on to the next question. Having a data management team plays an important part in the overall development and execution of a long-term data strategy. People want to know, how do you prioritize your hiring when constructing your personal data management teams? Mark, would you like to start?
Sure. Yeah, and I think, again, as Razi was saying, I assume we're talking about a startup here, and so thus we don't, we're going to be starting small, and I would say the first 1, 2, maybe even 3 hires should be leaning. There's a data scientist, and there's lots of different aspects to someone working with data. There's the ability to communicate. There's the business acumen. There's coding ability, there's math ability, there's and so there's experience in the domain. And I would say to start with, make sure you have someone who codes well, and you may even want to have one of your software engineers run them through their paces a little bit to make sure they're decent coding. They don't have to be able to build beautiful software artifacts, but they need to be able to code quickly and effectively. And I would say, hire someone like Ralph. You want a data engineer probably first, or you want an all-arounder, someone who can do some data engineering, can do some modeling. And I would just be wary of the hotshot deep learning PhD that looks great and may be great, but might also quickly become bored because they're not doing the modeling they want, and they did all this education in order to do this beautiful modeling on nice pristine data sets that they work with in the university, and that's just not the way it is in the real world usually. And I would again also be wary of Google and Facebook type FANG employees again who want to do the modeling and are used to having this massive sort of data cleaning, pipelining, plumbing, cleaning apparatus underneath them to help them not have to deal with that. You need someone who's going to be doing the cleaning and the data plumbing to start with, and that's my 2 cents on how to start building a team.
Those are excellent points, Mark. It's one other thing to add, maybe in a factor to consider at least. This has been my experience working with especially data scientists, for quite some time at DataRobot and other places. Sometimes we just underestimate the need for domain expertise and experience, and it just plays such a critical role. Lucinda, you were talking about healthcare, and just the data is so different compared to what you would do in banking. The models are so different. Even though fundamentally you were using very similar techniques, you may be using pretty much the same set of tools, but the application of those tools, the application of what I would call boring AI as opposed to the sexy AI that Mark you were talking about. But even then, it could be the same algorithm, but the models that you build, the way you kind of use data, the way you those models go into production could all be very, very different. And I think domain knowledge helps significantly, especially when communicating with the business. So hire people who have at least some domain knowledge or an appreciation for working in a particular business.
Absolutely. The domain knowledge is really key to really understanding use cases, et cetera, things like that. I wanted to just mention one other approach to building a data science team or capability, and that is to there are organizations out there where you can kind of rent the capability. So for example, for Ironside, I'm just going to show this one slide here. And that is kind of data science as a service, but we also kind of have analytics as a service as well. So this is, instead of, like, as you're thinking about building a data science or data capability, you've got the infrastructure, you've got the people, you've got the processes, you've got various monitoring, et cetera, that can really have a steep upfront ticket. Entirely agree with Mark and Razi about getting some get the data engineer first, and get some generalists, people who can collaborate, communicate, understand business, sell, do the work, etc. But also, you can also try it by going through a staged process and say, okay, use case discovery. If use cases are the things that drive business value, that give you the R in your ROI on your data investment, then look at different types of use cases and rank them in similar to the data viability that we showed previously. Then take the top ones, just do some quick and dirty modeling, or standing up a dashboard or whatever, and then say yes or no, we're going to go forward, and then build out the full machine learning or the full dashboard or whatever. And each one of these, you can work with organization that can do this quickly for you, and then transfer it over to yourself once you know what it is that you want to do and what you want to hire for. And then later on, deployment, monitoring, etc. So just kind of taking a double click on the use cases. You can this is very quickly just looking at data viability, which is the sort of thing that I talked about in the previous time. And then also the business viability. How much, value are you getting it for it? Are you, what do the subject matter experts, people who understand the industry, tell you about? This is a good way to run the business, and these are some attributes. So that's just another way of looking at it, in terms of, that you don't necessarily have to build and buy everything yourself up front. There may be other creative ways to get to where you need to go at a fraction of the time and the cost.
Very good, very good. Thank you. So transitioning on, I think it's pretty well known, the higher the quality of a company's prioritized data, the better and more efficient a company can and will operate. But how do we measure that? So I think that goes to our next question. What are some key metrics and insights that a startup should focus on? Just to go a little bit level deeper, how do you demystify your components of growth in order to develop and use these metrics? Anybody have anything to say? Or if anything, in that case, how do you measure growth, KPI, key performance indicator, or objective key results? Or should we not do that right early on?
I think I'll just jump in and maybe offer just my experience. For startups, revenue trumps everything else. So there, and for FeatureByte, we're an early stage company. We just raised around, our seed round was announced a couple of months back. So at this stage, there are only two things that matter: is what's the burn and how fast are you able to hire people, right? So that's the stage now. When we have a product, it's all about revenue. It's all about just not profitable growth, but how well you're faring against the competition, how quickly you're able to scale the business, and how repeatable the business is going to be. Those are the factors that start to become super critical. And the KPIs, the metrics that you can measure and gather over time, those change significantly depending on the stage of the company, as well as the industry you might be in, etc. So I know that's very generic, but I think just a few things at least to consider from a strategic perspective.
No, that's wonderful. Do you have anything else to add? from there before we move on? So moving on, we move to what are the characteristics of a good data model? So what are some things to consider prior to starting the data modeling process? Can we start with Lucinda, if you're comfortable?
Sure. Let's see. Well, I do think that one of the most important things is to understand how are you going to get value from the data, right? Because you have all this data, but if you analyzed everything, would that really do anything for your company? So just kind of going a little bit deeper on the use case, I'll just share this for a second here. Hold on. So, you know, there's the data viability, which is,
I believe
sorry, yes?
you're sharing the wrong. You're sharing the wrong thing. I can help
Okay.
out.
Okay. All right. Yeah. Do you want to put that one on? Interesting. Yeah, it's next one. Yeah, I've gone through this one. The data, that's the one. Yeah. Thank you so much.
No problem.
Ralph. Yeah. So in terms of the use case, I think it's important to look at what are the specific use case, because you're going to build a lot of capability around something, and whether it's from the data part, as well as if you apply machine learning, or you're doing analytics or a dashboard and you're supporting it and then you're monitoring it later on. It's important to, you know, understand what are the use cases that drive the value in your business. So it may be something like revenue forecasting, it may be fraud detection, you know, but there'll be a certain amount of how much effort does it take to actually do this, to make this application go live and do all the analytics and have the data flowing through properly. And so you just want to be able to look at the data viability, how good is the data, the quality of the data, and then look at the top use cases for what will be the returns. Sometimes these can be very complex to kind of anticipate. Sometimes you have to add some business judgment in addition to what you're able to actually quantify. So thanks very much.
No problem. Razi, do you have anything to add to that?
Sure. Yeah, I think maybe a couple of points to consider, especially when you're just starting off in a particular area with data modeling. You know, the key, I think, is to develop a really good understanding of the business first. So work with the business to understand, you know, what are the levers that are important for the business. Data should ideally be modeled as events happening in the business. That just makes it much easier. And then, you know, from a model point of view, just, you know, abstract the model, keep the model abstract enough so that it remains extensible, rather than just tying it completely to a specific, you know, operations of the business, which will evolve and change, obviously, over time. And maybe the last thing to consider is just, you know, something that's becoming more and more important for data professionals. And Ralph, maybe, you know, this is something that's squarely in your area, but defining data contracts between different parties, right? So it's the formats, SLAs, security, etc. That just makes it much easier for different groups to consume data, build capabilities on that data without having to, you know, going after people when things break and pipelines don't quite work as they were expected to. So those are some of the things that I feel are important things to consider.
No, very, very much so, very much so. Mark, did you have anything to add, or before we move on? All right. Going to the next question. What is the difference between data integrity and data quality, and why are they both crucial to developing a good data model? Lucinda, would you like to start again?
Yeah, sure. So I kind of talked about data quality very briefly previously, but there are some aspects of data quality that you kind of need to just look at, that are important. One of this, the completeness of the data. So do you have data for what you need for the various things that you're trying to analyze? Do you have unique data sets? In other words, have they been deduplicated? And that's actually really important because entity resolution can be super confounding. You may have things filled in kind of haphazardly and partially by different people, say on a CRM platform, and you're not sure, like, okay, is this department of a hospital or is this hospital the same one as the one that they're listing over there? Was there a merger? Was there a name change, et cetera? Or customers, by over-specifying customers, you can actually not realize that you're dealing with a loyal customer and you think that they're all new. So really the deduplication and entity resolution is extremely important. So that's the uniqueness of the data. The validity, like, does it conform to the structure and syntax that you want? I can't even tell you how many times we have to change formats of columns, et cetera. Timeliness, you get data, if you need data real time, can you get it real time? If you need it backed up since yesterday, can you get it? Or are there other confounding factors that cause a lag in the data, or that you have multiple lags in your data, which also may be confounding? And that it's consistently processed, defined, et cetera. The definition of a walkout for a retail chain is the same across all the different data that you're using. So these are 5 aspects of data quality. Data integrity is actually a little bit different than that. It includes data quality, but also includes the integration part of it, like how easily can you flow the data together. It also may include third-party data. So for example, I've done models where the R-squared might be like 0.2 or 0.3 on the model, and it says, okay, so only 20 or 30% of the variability is explained by these variables. What other features can I put in? What other to add to the data variety that will allow the model to actually take in more relevant data? So the enrichment actually is very important as well. So really, the integrity, data quality is part of data integrity, but the integrity is really how much of the whole picture you're getting.
That's great. That's great. Moving on. Would you encourage detailed documentation while creating data models? Why, if so, and why not, if not? And I know we had some contrarian opinions on the light of this. If anyone wants to start, Razi, would you like to start? I see you smiling.
Yeah, I think no, documentation is super critical because the data models that you define ultimately drive the consumption of the data, right? So the value from data gets created when it's consumed, whether in a report, in a dashboard, or some kind of model, right? And without good documentation, without some structure around the data itself, consumption, you're basically just making downstream consumption that much harder, and just limiting the value that you can derive from that data. So I feel documentation is critical. Contracts are a good way to think about how you publish data. It just allows different groups within an organization to publish, and completely independent organizations to perhaps consume that data in a meaningful manner. And when things break, you pretty much know, okay, well, who to go to, and what are the kinds of things that need to be fixed in order for me to continue serving up a model that's driving an important facet of the business. Right? So yeah, I'm very much about making sure that data is documented. And yeah, I'm sure, Lucinda, as a data scientist, you've seen data that's that you have to constantly go and chase after people to understand what the hell it's all about. And I'm sure, Mark, you've got that experience as well from a data science point of view.
Yeah, and I guess the only thing I would add is just when you're in a startup and you're moving fast, and or even if you're a place at like Facebook and you're moving fast, it's difficult to move fast. And also do that documentation. And and as soon as you write that documentation, it's already out of date because the people have changed what they're doing. So you have to make it very easy. And I think in some ways, it's the code in the end that is what is the documentation of what a particular column is. And so you have to make sure it's easy to get at the code, and make sure there's people have the capability to look at the code and figure out what's going on. And then the documentation needs to be right in the code, and you need to extract it out of the code in an automated way. It's difficult when you're moving quickly to have some separate document that is saying this is what this is, unless that thing is very stable. And in my experience, those tend not to be that stable, at least for quite some time. So, yeah.
No.
So I would add just a couple of other thoughts. One is that, there's documentation about this is, first of all, embedding documentation in the code. Absolutely. If it's not there, it's just, oh my gosh, it's like you have to almost reinvent the wheel. So, and anybody out there who's ever been on a project where you've been brought in and the person who built it left knows this, right? But another aspect is I would make distinguishing between the kind of this is this and that is that documentation and process documentation. So for example, you could get a really good solution documentation that tells you where everything is. However, the process by which you retrain a model, or you deploy it, or you move it from customer testing to full production deployment, I think those types of process documentation end up being important as you implement things and you do things at scale.
Very important as well. Also, a good data model should have data inside, as like you guys already touched on, should be easily consumed. It should be able to take in large changes at a scale, and also provide a predictable performance as well. So that is the end of the prepared questions. We will now open it up to the audience. Please submit any questions that you have for our knowledgeable panel, and we will reach out. I'm looking at one right now. It has 3 votes, and we will share it to the screen for the panel. Further, how do you determine when the cost of the data no longer justifies its value as measured by its use or some other metric as defined in the previous question? So I'm assuming that is in regards to what are some, how do you measure the value that are extracted over time, but data sources not directly attributed to the revenue action. I believe, Lucinda, you touched on that, correct?
Yeah. How do you measure the value? The one that's showing here right now is how do you measure the value, the return being extracted over time by data sources that are not directly attributable to revenue creation. Yeah, I mean, I think part of it was kind of mentioned in the previous question, which is it being used? I mean, another part of it is sometimes you can say, well, I really would like to have all this data, but it's really expensive to keep up. So you may say, okay, instead of collecting 2 years of data, we're gonna, for this particular thing, we're gonna do 2 months of data, and then you just limit it. But then you need to be able to capture some snapshots along the way. So in terms of the return, there are a lot of different ways to measure.
I want to ask. Let me just, Lucinda, sorry. I just want to add in to the point you were saying about the time. It depends what you're going to do with it. Like if you're going to do a lot of forecasting, for example, you can't just say, "Oh, I got all the data now." That's useless. You have to have a backlog of data. So it depends if you're going to be training a model or that has some kind of temporal aspect, then you have to have that data. That's all I know.
Yeah, absolutely. Yeah, you need usually like at least 2 years of data to capture seasonality if the business isn't seasonality. But other ways to measure return are, one way is revenue. Is there a difference in revenue? And you can do this with controls, like you say, okay, I have model A and these many stores or this many situations are using model A, this many situations are using model B. Or you could do a before and after comparison to see what the revenue change might be. Also, margin and profit is another way of measuring things. Also, NPS scores, customer satisfaction, whatever you have. So those are different things. So, for example, in a retail setting, if you decrease the number of walkouts fast food store, then there may be higher customer satisfaction as well. So there are different ways to measure business value that are not revenue or margin.
I mean, also if you're,
go ahead, Mark.
Just real quick, it could be that that the piece of data is feeding some predictive model or some modeling thing, and then you can look at the drop in accuracy that occurs when you pull that piece of information out.
Yeah, Raza, you were gonna add something too?
Yeah, Ralph. So one of the things I just wanted to add to what Lucinda was saying is also think about the risk that's being created, because sometimes we focus a lot on the top line and the bottom line. So it's all about revenue, profitability, etc. But sometimes models may contribute to reducing risk for the business, and you want to just have a measure of how if the data source may be tied to some potential risk, whether it's fraud or AML, anti-money laundering in banking or financial services types of organizations, or some health risk in healthcare and hospitals, etc. So that's another factor to just layer in.
Okay.
I'll say I've also been parts of businesses that wanted duplication in their data sources in order to reduce the risk of one going down, one having the prices being raised, or a competitor buying that data source, and then you don't have access to it anymore. So to build on what Ozzy was saying with respect to risk reduction, sometimes data sources are there and to provide a duplicate redundancy.
Makes sense.
Thank you. We have one more question. I will share it. It is further, how do you determine the cost of the data no longer justifies the value as measured by its use or some other metric as defined in the previous question? I'm so sorry. So that was, I believe that's based upon the previous question that Lauren just asked. So based upon the measurement of R return, how do you determine the cost that the data no longer justifies its value based upon return?
I think we kind of answer that, right? That it's it's along multiple metrics as we just discussed all the way from revenue, profitability to risk, and yeah.
No problem. Next we have from Jen Green. Data is on the quantitative end of the spectrum. Customer experience is a blend of that as well as qualitative. Do you have recommendations on how organizations should strike the balance between consuming the information? This also extends to how should leadership / product negative data paralysis or overcome missing data when making decisions. Give the panel time to read that over again and formulate that.
I mean, I think there needs to be a sophistication up and down, and I think Lucinda mentioned this earlier. So, talking about data, talking about metrics, at your quarterly reviews and monthly meetings, so that leadership gets used to the warts and the and the gems, all the problems and the good things and the difficult things with different metrics. So they get used to it in the same way that people get used to looking at how the stock market moves, or how NASDAQ moves, or how and understand that, yeah, because Apple is this huge portion of the NASDAQ, if something happens in Apple, it doesn't mean the entire NASDAQ is collapsed. So that kind of sophistication, I think, needs to be built up along the entire company. And so I think talking about data and talking about metrics at every, at any of these sort of key presentations is to lay that foundation or that scaffolding can then help people. Because I think the question is basically saying, hey, look, it's the metrics aren't everything. And yet they're also not pointless. There's some kind of balance. And I think the only way to get there is to practice and build that muscle. That's what I would call it. Build the muscle in the organization to understand when it's important and what it can and can't do.
I think that sometimes, okay.
I was just going to add to what Mark was saying, that that's a great analogy of the market, that it's, when you're investing, for example, you don't look at what happens every hour to decide. Of course, some hedge funds may do that, but as regular investors, we don't look at what's happening every single hour to determine, okay, well, should we invest or should we rebalance our portfolios and stuff like that. I think it's a great way to look at the long term versus short term. There are certain strategic decisions you take all the time as a business where there is literally no data, right? Or the data is going to be completely incomplete. To talk about oxymorons, right? Because you're marching in a certain direction and you're placing a bet. That's one example where, yes, you want to consider the data, but you want to take a lot of quantitative inputs into consideration before making big bets. And there are other situations where there's something called doing the right thing, right? So it's your data may lead you in a different direction. For example, a customer situation where if you went and resolved a customer issue, perhaps it's just going to cost you a whole lot more than you expect, that the value you may derive from the customer. But you may have a whole bunch of other qualitative benefits from solving the customer's problem, keeping them and having them, go off and present your business in a really good light. So data is super important for making decisions, but I wholly agree with the sentiment here from Jen that yes, it's a combination of both the long-term thinking as well as qualitative thinking combined with quantitative and database thinking that businesses need to adopt. Sorry, Lucinda, jumped in.
Yeah, just a very brief point to build on both yours and Mark's comments, which is that sometimes the data can tell you things that people can't, and the people can tell you things that the data can't. So you may find interesting things in a data and say, like, why is that? But then interviewing the subject matter experts, having a focus group if you're doing marketing, that you do need that context that comes from speaking with people to kind of give the context to the data. And the data will tell you may hear a lot about something, but it's not very important. The important thing is this. Then you can go dig and find out, okay, what are the qualitative aspects of that?
All right, and we have one more question here. This is from Maureen, and we still have 10 more minutes. When building a startup, I've heard two trains of thought. First is to hire a generalist or hire a classically trained computer scientist. What do you recommend? That's from Maureen.
So I actually just typing out an answer to that. I'll just say it. Yeah, I mean, I think there's lots of people who can code quite well, who are not classically trained with a CS degree. So I've hired many physics people out of physics, experimental physics, or chemical engineering. Hired 2 different chemical engineers and electrical engineering, and that's worked out great. Some of them are the biggest coding machines around. And so I don't think you have to have a classically trained. You need someone who can code pretty well. And it is true that there are a lot of data scientists who can't. They're basically able to write like a script, essentially. They don't really understand they can't think algorithmically. They don't really know what it means. There's something that grows to the cubic with respect to the input data size and things like that. And so that's a risk. But I think you're going to have a unicorn if you want someone who has a CS degree and knows your domain and has good math skills and business acumen and so you need to sort of figure out what you want. And what I was saying earlier was, I think you need someone who can code. They need to be a can-do kind of person, but they don't have to write beautiful code, because it's a lot of the stuff you do in data science is it's either throwaway or it fits into a framework that doesn't require building some large software engineering project. So yeah, that's what I think. I think you have to get someone that has that you need to test. Take one of your software engineers and have them run through their paces to see, can this person code well enough, or have some kind of take home that again is evaluated by a CS person. But make sure that you also tell that your CS, your software engineer, they don't have to be a software engineer that's gonna write a ton of reusable code. They need to have some sort of basic capabilities and test for that.
That's great. And just so I get this little point in here, because we did skip over it and that was my mistake. We still need to address what are some data collection reporting tools a startup can use. Razi, since you just rejoined us, are you okay with segueing in and starting that off?
Sure.
Do you have a
Sure,
checklist or anything like that?
Yeah, not sure what happened, but at least I'm back. So
Yes. Glad you're back.
yeah, I think instead of maybe talking about the checklist itself, I tend to think about the tools in terms of 3 different aspects of data management: collection, capture, and then the consumption and analytics, right? So when it comes to collection and capture, which is collection is all about ETLing data and bringing it from a variety of different sources, and then capture is all about data warehousing, data lakes, and maintaining that data within the business. And obviously, analytics is the consumption, whether it's ML, visualization, etc. Especially for startups or even medium-sized companies, I think it's best to think about centralizing collection and capture. So that's where you want to figure out, okay, well, are there common tools that can be used? Because those are fundamental. Those are pieces of the infrastructure that are fundamental to build capabilities on, and it's good to have a solid foundation on which you build a lot of different consumption capabilities. When it comes to consumption, the different groups, different teams within the business, as well as different aspects of the business, have very, very different needs. All the way from reporting to ML modeling, etc. And that's where it's one tool or a couple of tools to solve everyone's problem is probably not a good approach. So instead of a checklist, I thought it's worthwhile at least sharing how to think about just using tools that everyone in the enterprise can use versus things that are much more distributed.
No problem. And Mark, how do you compare analytical tools? Do you have anything to add to that?
Yeah, I mean, I guess I've always been, again, a startup, you're assuming that you don't want to spend a lot of money and really sink a lot of, so I would go with what, first of all, open source. I would, pick your decision, pick whether or not you're going to do R or Python based work. I would recommend Python personally. but for a number of reasons. But someone could ask about that if we want. And then I would say work with whatever cloud. Work with managed services. Don't try to spin things up yourself if you can. If there is, Airflow is a common data pipelining tool, and instead of managing it yourself, use the one that Google Cloud Platform provides to you, or analogous in AWS. If you're, assuming you're probably doing things in the cloud. So work with the tools that are there. Try to avoid spinning up your own things and go lowbrow to begin with until you understand your use case really well, and then you can perhaps purchase something that really matches your use case and makes your life easier. But I would wait on that and try to leverage what's in the cloud already, the platform, and any open source tools that are easy.
No problem. Thank you. Lucinda, do you have anything to add to that before we jump back into?
Definitely agree with using open source, etc. Definitely agree with really thinking carefully about what the end user is and what do they use, what do they know, etc. So yeah, I don't have much to add other than what was mentioned here.
No problem. So we have
remember,
one.
you have to hire. You have to hire too. If you take something that's some kind of weird side thing, you have to be able to hire for it, which is hard. Like even like MATLAB, for example, might be harder to get people depending on where you are. So, anyways, go ahead. Sorry.
And we have one last question from the audience. Thank you, Sadia. Following Maureen's question, for those who haven't taken the traditional route in computer science, how do you see self or community taught engineers contributing value to companies just starting out, especially in a startup? Do any of you guys have anything?
Yeah, go ahead. Most of the people. Yeah, go ahead, Rossi.
Good, Mark. Good.
I already said that most of the people I've hired into the data science role are not classically trained computer science people, but they might be PhDs in neighboring fields, and so but they don't have that set of courses, but they taught themselves. So I rarely work with a CS person. The 10-person team that I work with at Facebook, I was the only one with a CS degree.
Anybody else? Razi?
Lucy. Go ahead, Rossi.
Sure, thanks. So just my experience is not very different from Mark's. So just talking about our own startup, the CTO, our CTO at FeatureByte, he's a bioinformatics PhD, not a classically trained CS person. I would say it's half and half. So half of the folks come from non-CS backgrounds, from physics, from actuarial science, folks who just like to build stuff and like to code. I think, that's maybe more important in some ways than and have a passion for developing really good a really good example is one of the UI engineers who was just amazing on our team. He's a chemical engineer who spent 10 years in chemical engineering, and then suddenly decided that he's just fascinated with building user experiences and UIs. And then he switched, and he's been doing that for 3 or 4 years, and he's much better than a lot of the classically trained CS folks that I've seen. And I'm a classically trained CS person, and I haven't touched code in like 25 years. So it's what you find is folks come from different backgrounds, but then their passions change over time, and you always want to look for people that have a strong passion for whatever it is that they need to do. Outside of that, where their what their background has been maybe is not as important.
That's great. Lucinda, did you want to add to that?
Yeah, just building on the points from Mark and Razi. So I do feel like a lot of these things are evolving even as we speak, right? I mean, Mark, you'd mentioned, Python versus R. Well, it can change, right? But another aspect of this is that people who have been either self-taught or community taught, who have an engineering background, they have a way of thinking about numbers and data. They're not afraid to do that. If they're interested in learning, if they have, they might be able to start out as an analyst, for example, but then continue building their machine learning capabilities in either side projects or outside work, or even within work. I think that it's very much an evolving skill. You mentioned the unicorn is, somebody who can talk to customers and clean data and, set up a machine learning model and deploy it and monitor it, right? Well, a lot of these jobs now that are coming out now, like the ML ops person might be a DevOps person who understands machine learning and the special needs of that, right? So you can do a little bit of a pivot there. There's also, ML engineers, et cetera. So there are a lot of different positions that are kind of emerging right now that need people who understand a little bit about machine learning or data analytics, but they're able to pull together different disciplines. So I guess it's a long way of saying that, it's really evolving, looking for people who are adaptable, who learn, and also have a demonstrated ability to get things done and deliver on things. And I think is really important as well. So I just feel like the whole thing is kind of bubbling and churning. And if you keep your eye on things, you can find through your contacts and through different opportunities, different ways to build up expertise and skills that are rare and valuable.
Thank you all. Thank you all. With just 1 minute left on the clock, I guess. This is just off topic, just to decompress, right? We've been talking about data. This will just be a rapid fire. If each one can just ask, if you could have dinner with anybody dead or alive, who would it be? Don't even think about it. Just let it go. It's bad when you think. It's bad when you think.
All right, I'll start. Leonardo da Vinci, the fact that guy was able to have his mind span across all these different disciplines, think about things that were not constrained by whatever materials or technology existed at the time, would be really cool to just understand how that mind thinks and works.
Razi and Mark, with less than 30 seconds.
Steve Jobs, it's just such a colorful character. I'd love to, just get a little bit of insight into how that guy used to think.
And Mark,
I'll go with Euler. He's also Swiss. I have Swiss descent, but also just a huge mathematician. Also lived in Russia for a number of years and had a huge number of children, and seemed to be just kind of like a mellow guy, even though he generated unbelievable amounts of math.
That's great. That's great. Thank you, guys. Thank you so much for your time.
Thank you very much, Ralph, for your moderating and your thought for putting this session together.
Thank you guys for dealing with me and giving me patience. Thank you.
No, it's great.
Pleasure. Thank you,
Awesome.
Ralph.
Appreciate everyone on the panel. If you're in person at the Cambridge Innovation Center, feel free to take a 15-minute break. We have another session at 1. If you're virtual, feel free to join us for that, or you can check out the agenda page for more sessions going on virtually. Appreciate your time. Thanks, everyone, for a great session, and we'll see you soon.
Bye-bye.